بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is section 3.6 derivatives of logarithmic and inverse trigonometric functions. And let us start by derivatives of logarithmic functions. If you remember, the definition of the logarithmic function is y equals log x to the base b if and only if x equals b to the power y. So using this formula, we can change the logarithmic form into exponential form and vice versa. The derivative of log x to the base b is 1 over x times ln b. So for example, if we want to find the derivative of log x to the base 2, then the derivative would be 1 over x times ln 2. And for ln x, remember that ln x is log x to the base e, and that ln e is 1, and ln ex is x. So to find the derivative of ln x, we can just use this formula, and write 1 over x times ln e. But ln e is 1, so the derivative of ln x would be just 1 over x. And if you want to use instead of x u, a function of x, g of x, so using the chain rule, the derivative would be 1 over u times u prime, or you just write it u prime over u. So the derivative of ln u would be u prime over u. This formula, we can find this formula, okay? We can prove it from this definition here. If y equals log x to the base b, if we call this function y, then x is b to the power y. And now we can take the derivative of both sides of this equation with respect to x. Derivative of x is 1, and derivative of b to the power y is b to the power y times ln b times y prime using chain rule. So y prime would be 1 over b to the power y times ln b, but b to the power y is x. So y prime is 1 over x times ln b, and that's the proof of the formula. So that's the derivative of log x to the base b. So for example, find the derivative of ln x cubed plus 1. So we use this formula, and y prime would be 1 over x cubed plus 1 times the derivative of x cubed plus 1, which is 3x squared. And here, the chain rule, and also if you write u as g of x. So you write it g of x or write it u, the derivative would be always g prime over g or u prime over u. So the derivative of this function would be 1 over sine x times the derivative of sine x, which is cosine x. You can leave it like this, or you can just write it cotan x, because cosine over sine is cotan. Now here, what do you have? We have a square root. So the derivative of the square root, if you remember, is 1 over 2 times the square root. Then times the derivative of ln x, the radicand inside the square root ln x. So derivative of ln x is 1 over x. So the final answer would be 1 over 2x times the square root of ln x. This would be the derivative of this function using the chain rule. Find the derivative of this function. Okay, f prime of x is, this is a logarithmic function, so the derivative is 1 over 2 plus sine x times ln 10, because the base here is 10. Although if you remember, we do not write the base 10. If the base is 10, we just say log 2 plus sine x. So times, so this is f prime, okay, 1 over x. So if you have u, it is 1 over u times ln 10 times the derivative of u, which is 2 plus sine x. Derivative of 2 is 0. Derivative of sine x is cosine x, and that would be the derivative of this function. Here, find the derivative of ln. Well, I can use here the properties of the logarithmic function. Remember that ln u over v, I can write it ln u minus ln v. And ln u times v can be written as ln u plus ln v. And ln u to the power r can be written as r times ln u. So I can write this as d by dx of ln x plus 1 minus half ln x minus 2, where square root of x minus 2, I wrote it as x minus 2 to the power half, and I used this property to bring half out like this. If I write it the function in this way, then the derivative would be easy. Derivative of ln x plus 1 is just 1 over x plus 1 times 1 minus half. The derivative of x minus 2 is 1 over x minus 2 times 1, the derivative of x minus 2, and that's it. That would be the answer. Well, here, f of x equals ln absolute value of x. Find the derivative. To find the derivative, let me first write the definition of ln absolute value of x. This function has two definitions. Either it is ln x if x is positive, and it is ln negative x if x is negative. So this is f of x. So f prime of x would be derivative of ln x is 1 over x if x is positive, and the derivative of ln negative x is 1 over negative x times the derivative of negative x, which is negative 1. So it would be also 1 over x. So in fact, f prime is just 1 over x. Whether x is positive or negative, the derivative of ln absolute value of x is just 1 over x. This is an important formula to remember. Now, let us talk about what we call logarithmic differentiation. In logarithmic differentiation, we use it to find the derivative of functions like this. Well, to differentiate this function as usual, I have to use the quotient formula. And then when I use the quotient formula, the derivative of the numerator, I will use the product formula. And there is also chain formula. So really, it would be ugly to find the derivative if the function is written like this. But we can use logarithmic differentiation to simplify this function first. How? We take the natural logarithms of both sides of the equation. So I start by saying ln y is equal to ln x to the power 3 over 4 times square root of x squared plus 1 over 3x plus 2 to the power 5. Then I use the laws of logarithms to simplify. These are the laws of logarithms, the three laws of logarithms. We use this to simplify the right-hand side. So I can write ln y equals. I have quotient, so and product, okay? So let me write it for the first time and write all the steps. So ln the numerator minus ln the denominator. Then here I have product, so I will write it ln x to the power 3 over 4 plus ln square root of x squared plus 1, and here minus ln 3x plus 2 to the power 5. And now I can take 3 over 4 out. And this one I can write it to the power half and take the 1 over 2 out. And here the 5 also can be taken out. And now this is written in simplest form. So now I can differentiate implicitly with respect to x. So I find the derivative with respect to x. The derivative of ln y with respect to x is 1 over y times y prime using the chain rule equals. The derivative of this is 3 over 4 and the derivative of ln x times 1 over x plus half times 1 over x squared plus 1 times the derivative of x squared plus 1, which is 2x, minus 5, 1 over 3x plus 2 times the derivative of 3x plus 2, which is 3. So finally, I can solve the resulting equation for y prime and replace y by f of x. So I can write it y prime equals all of this times y. Can multiply both sides by y. So here I have 3 over 4x, and here 2 cancels with 2, and I will have x over x squared plus 1, and here I have 15 over 3x plus 2. And finally, I can write y prime as 3 over 4x plus x over x squared plus 1 minus 15 over 3x plus 2 times y, and y is originally x to the power 3 over 4 times square root of x squared plus 1 over 3x plus 2 to the power 5. So this would be the derivative of this function using logarithmic differentiation. In general, we have 4 cases for exponents and bases, all right? And pay attention to this. Constant base and constant exponents, like 2 to the power 3. What is the derivative of 2 to the power 3? Because it's a number, so the derivative would be 0. What if we have variable base? So for example, x squared plus 1 to the power 4. What would be the derivative and constant exponents? Well, the derivative of f of x to the power n is n f of x n minus 1 times f prime. So the derivative would be x4 times x squared plus 1 to the power 3 times 2x. Well, we could have also a constant base, for example, 4 to the power x squared plus 1, and variable exponents. So what would be the derivative of 4 to the power x squared plus 1, or b to the power g of x? It is b to the power g of x times ln b times g prime. So the derivative would be 4 to the power x squared plus 1 times ln 4 times 2x. The last case which we are going to talk about today is when we have variable base and variable exponents. So for example, x plus 1 to the power x. How to find the derivative when you have a variable base and variable exponents? Well, here we will use logarithmic differentiation. We will use logarithmic differentiation. For example, find the derivative of this function. So the first step is to apply ln to both sides. And then we use the properties of ln to bring square root of x down. And now we find the derivative with respect to x. The derivative of ln y is y prime over y. And the derivative of square root of x times ln x, we use the product formula. Derivative of square root of x is 1 over 2 square root of x times ln x plus square root of x times the derivative of ln x, which is 1 over x. And now I can write it y prime equals, here I can write ln x over 2 square root of x, and here square root of x over x, it can be written as 1 over square root of x, because this is x to the power half and this is x to the power 1 times y, and finally y prime would be y, which is x to the power square root of x times ln x over 2 square root of x plus 1 over square root of x, and this would be the derivative of x to the power square root of x. Well, the number e as a limit. We can express e, the limit, as the limit of 1 plus 1 over n to the power n when n approaches infinity. We can prove this from the definition of, if we take the function f of x equals ln x. We know that f prime of x is 1 over x. So we know that f prime at 1 is 1 over 1, which is 1. But f prime of 1, by definition, if you remember, is the limit when h approaches 0 of f of 1 plus h minus f of 1 over h. And we can write this as limit. We can replace h by x. So x approaches 0, 1 plus x minus f of 1 over x. And f of 1 plus x, now f of 1 plus x, f is ln x. So f of 1 plus x would be ln 1 plus x. And f of 1 would be ln 1. And ln 1 is just 0 over x. So this is 1 over x ln 1 plus x, or we can write it ln 1 plus x and take the 1 over x here above. So we can say that limit, of course, the limit is there. I forgot the limit here. It is everywhere. Okay. So here the limit when x approaches 0, the limit when x approaches 0, the limit when x approaches 0. So the limit when x approaches 0 of ln 1 plus x to the power 1 over x is equal to f prime of 1, and f prime of 1 is 1. So this is the first equation here. So limit ln 1 plus x to the power 1 over x when x approaches 0 is 1. And now if ln 1 plus x to the power 1 over x goes to 1. So if you raise both sides to the power, to the base e, then e to the power ln will go to e to the power 1. E cancels ln. So we can write that limit 1 plus x to the power 1 over x when x approaches 0 will be the number e. And we can, if we write x, if we take x as 1 over n, then when x approaches 0, n approaches infinity, and we can replace x by 1 over n and 1 over x by n to get to this limit. So we will use this limit later on. We will need this fact that e is the limit when n approaches infinity of 1 plus 1 over n to the power n. Now let us talk about derivatives of inverse trigonometric functions. You know, inverse trigonometric functions, sine inverse, cosine inverse. We studied these functions before, and there was a domain in which we choose for each trigonometric function to be able to have an inverse, because the trigonometric functions are not one-to-one. So for example, to find the derivative of sine inverse x, we can find it easily by doing this. Well, we write y equals sine inverse x, and the definition of sine inverse, if you remember, if y equals sine inverse x, then x equals sine y, okay, where y is the domain of sine, and it's between negative pi over 2 and pi over 2. In this domain, sine is 1-to-1, and we can define its inverse. Now, for this function, if I find the derivative with respect to x, then the derivative of x is 1, and the derivative of sine y is cosine y times y prime, using the chain rule. So y prime would be 1 over cosine y, okay? But cosine y is square root of 1 minus sine square y, because cosine square plus sine square is 1. Well, cosine y could be positive or negative square root of 1 minus sine square, but since we are in the fourth negative pi over 2 to pi over 2, we are in the first or the fourth quadrant. So here cosine is positive, so it's a square root of 1 minus sine square y. And sine square, sine y is x, so this would be 1 minus x square. So if y equals sine inverse x, y prime equals 1 over square root of 1 minus x square. So the derivative of sine inverse x is 1 over square root of 1 minus x square. You can do this for all the other 5 trigonometric functions and find their derivatives, and you will find that these are the derivatives. Derivative of cosine inverse is exactly similar to sine inverse with a negative sign. Derivative of tan inverse is 1 plus 1 over 1 plus x square, and cotan inverse would be the same with a negative sign. Derivative of secant is 1 over x times x squared minus 1, and the derivative of cosecant would be the same as secant with a negative sign. And of course, you can use the chain rule here, and you can replace x by u. So for example, to find the derivative of sine inverse u, you will have 1 over square root of 1 minus u square times u prime. You can do that for all the other uh, 5 formulas. So here, for example, differentiate this function. Well, y would be equal. Let me, okay, I'm not going to write it like this, but I remind you that the derivative of 1 over u, okay? What is the derivative of 1 over u? What is d by dx of 1 over u? We wrote this before. It is an important formula. Keep it in your mind. It is negative 1 over u square times u prime, or just negative u prime over u square. So here, in fact, I have 1 over u, and u is sine inverse. So y prime would be negative 1 over sine inverse x to the power 2 times the derivative of sine inverse, which is 1 over square root of 1 minus x squared. Derivative of sine inverse is 1 over square root of 1 minus x squared. So that would be the derivative of 1 over sine inverse x. Remember, 1 over sine inverse x is not sine x. Okay, this is not true, because sine inverse is this function. This is the definition of sine inverse. It is not 1 over sine. 1 over sine would be sine x to the power minus 1. So sine x to the power minus 1 is not sine inverse x. There is a difference between them. Well, here I have a product formula. So I use the product formula. F prime, the derivative of x is 1. And remember, arctan is just tan inverse. It's another way to write tan inverse. So 1 times arctan, or tan inverse square root of x, plus x times. Now, what is the derivative of tan inverse square root of x? It is 1 over 1 plus u square, or square root of x to the power 2, times the derivative of square root of x, which is 1 over 2 square roots of x. So that's the derivative of tan inverse, 1 over 1 plus x square, or u square if it is u, not x, and then we multiply by the derivative of u. So I can write it as tan inverse square root of x plus, well, here I have x, I have square root of x below, so I can x to the power 1 minus x to the power half would be square root of x. So I will have square root of x in the numerator, and in the denominator I have 2 times 1 plus square root of x square. And the square root of x to the power 2 is just x. So this would be the answer. Square root of x over 2 times 1 plus x. That's the derivative of f of x. Finally, let us find the derivative of secant inverse x squared. Well, g prime would be, this is secant inverse of u. The derivative is 1 over u, which is x squared, times u squared, which is x to the power 4 minus 1, times the derivative of x squared, which is 2x. So this is exactly the chain rule. Derivative of secant inverse 1 over x times x squared minus 1. If it is not x, if it is u, you write 1 over u times square root of u squared minus 1 times the derivative of u, 2x, or you can cancel this x with the square here, and you can write the final answer as 2 over x times x to the power 4 minus 1. I hope you enjoyed this section. Have a nice time and study hard.